Have you ever looked up at the night sky and wondered about the stars? They twinkle like tiny diamonds scattered across a vast, dark blanket. But these are not just little lights. Each star is a giant, fiery ball of gas, incredibly far away. We are about to go on an amazing journey, an adventure through space and time. We will discover the secret life of a star from its very first spark to its spectacular end. It's a story that connects everything in the universe, including you and me. Imagine you are an astronaut in a super-fast spaceship. You are zooming past planets and moons, heading out into the deep, dark emptiness of space. The stars welcome you, blinking messages from billions of years ago. Our journey will not be measured in miles, but in light years. The distance light travels in a whole year. This adventure will take us to the very places where stars are born, live, and die. We will see how these magnificent celestial bodies come into being, how they spend their long lives shining brightly. It's the greatest story in the universe, and we are just getting started on this incredible cosmic quest. It has heroes, which are the stars themselves, full of power and energy. It has a magical setting, the vast and beautiful universe. We will see how stars are like cosmic engines creating light and heat that can travel across unimaginable distances. This journey will show you that the universe is not just empty space. It is a dynamic, active place where amazing things are happening all the time. Our mission is to understand the universe a little better. By following the life of a star, we are also learning about our own origins. The story of the stars is our story too. Every atom in our bodies, every rock on our planet, was once forged inside one of these celestial furnaces. So, as we begin this adventure, remember that you are not just an observer. You are part of this cosmic story. You are made of the very same stuff as the stars. Let's buckle up and prepare for launch as we travel into the heart of the cosmos to witness the incredible saga of a star's life. Our first stop on this amazing journey is a place called a nebula. Imagine a giant, beautiful cloud floating in space. It's not a cloud of water like the ones on Earth, but a cosmic cloud made of gas and dust. These nebulae are the nurseries of stars. They are where new stars are born. What is the magic that starts it all? It's a force you know very well: gravity. In a nebula, gravity starts to pull the tiny specks of dust and gas together. Slowly, over millions of years, these particles clump together. As more material gathers, the clump gets bigger and bigger. This growing ball of matter is called a protostar, like a baby star, not yet shining but warming and getting denser. Squeezed tighter and tighter, the core becomes incredibly hot and dense. The temperature rises to millions of degrees Celsius. It gets so hot that a very special process begins. This is nuclear fusion. The protostar awakens and becomes a true star. A spark ignites an engine that will burn for billions of years. With a tremendous burst of energy, the star is born. Nuclear fusion turns hydrogen into helium in the core. A huge amount of light and heat is released, pushing outward. Outward push balances gravity's inward pull. The star stabilizes and shines brightly. It graduates from the stellar nursery, a young main sequence star. It begins the longest, most stable part of its life, a shining beacon, ready for its brilliant journey across the galaxy. Now our star has entered the main part of its life. This is called the main sequence. It's the long, peaceful middle of the star's story, like the adulthood of a person's life. For millions or even billions of years, the star will shine steadily and brightly. Our own sun is a main sequence star. It has been shining for about 4.6 billion years, and will continue to shine for about another 5 billion years. During this time, the star is a cosmic power plant. Deep in its core, it turns hydrogen into helium through nuclear fusion, releasing a constant stream of energy that travels out as light and heat. Think of the star as a hero on a long, important mission. Its job is to shine. Its light travels across the vastness of space, illuminating planets and other celestial bodies. For a star like our sun, this light brings warmth and energy to planets like Earth, making life possible. The star is a reliable and constant source of power. The balance between gravity pulling inward and fusion pushing outward is perfect. Not all stars are the same during this long middle age. Stars come in different sizes and colors. Smaller stars, called red dwarfs, are cooler and dimmer. They burn hydrogen very slowly, so they can live for trillions of years. Larger stars are much hotter and brighter, often shining with a brilliant blue-white light. These massive stars live fast and burn brightly. They use up their fuel in just a few million years. The size of a star determines its destiny and final chapter, but nothing lasts forever. Eventually, the fuel in its core will start to run out, and the star will prepare for its spectacular final act. After billions of years of shining, our star begins to run out of hydrogen fuel in its core. The long, stable period of its life is over, and its grand finale begins. The ending of a star's life is one of the most dramatic events in the universe, and it all depends on the star's size. Let's first follow the path of a smaller star, one similar in size to our Sun. When its hydrogen is used up, the delicate balance between gravity and energy is broken. Gravity starts to win, squeezing the core. This makes the outer layers of the star expand, cool down, and glow red. The red giant is so enormous that if our Sun became one, it would swallow up Mercury, Venus, and maybe even Earth. After a while, the red giant can't hold on to its outer layers anymore. They drift away into space, forming a beautiful glowing cloud of gas called a planetary nebula. It looks like a cosmic ghost. At the center is the star's core, which has collapsed into a white dwarf. It's about the size of Earth, but incredibly heavy. Now let's see what happens to a much bigger star, a true cosmic heavyweight. When a massive star runs out of fuel, gravity causes it to collapse suddenly and violently. This collapse triggers a massive explosion called a supernova. For a short time, the exploding star can outshine an entire galaxy of billions of stars. It's a truly grand and epic finale, sending a shockwave of energy and newly created elements hurtling through space. If the original star was very massive, the core might collapse into a black hole. A black hole has gravity so strong that nothing, not even light, can escape it. If the star was smaller, its core might become a neutron star. A single teaspoon of a neutron star would weigh as much as a mountain. These dramatic endings, white dwarfs, supernovas, neutron stars, and black holes, are the final, awe-inspiring chapters in the life of a star. Our cosmic adventure has shown us the amazing life of a star from its birth in a nebula to its final, incredible end. But the story doesn't truly end there. When a star dies, it sends all the elements it created: carbon, oxygen, iron, the very building blocks of planets, moons, and even life itself. The iron in your blood, the calcium in your bones, and the carbon in your muscles were all created inside a star that lived and died long before our Sun was even born. These elements traveled across space for billions of years until they became part of our Sun, all the planets, including Earth. The atoms that make up you, your friends, your pets, and everything you see around you were forged in the heart of a star. As the great astronomer Carl Sagan said, "We are made of stardust." Every time you look up at the night sky, you are looking at your own cosmic ancestors. The stars are not just distant, cold lights. They are the furnaces that created the ingredients for life. This cycle of birth, life, and death is what makes the universe so dynamic and alive. The story of the stars is the story of us all.